Today I want us to look at how we can look at this question, which says line L passes through the point P, that is 8, 6, and perpendicular to the line 3y plus 2x plus 6 equals to 0. Full stop. Find the equation of the line L and write it in the form y equals to mx plus c. So in this case, it is what the guiding part here is perpendicular. We are told these lines are perpendicular. So because they are perpendicular, we want to look at the equation of this line passing through the point 3y plus 2x plus 6 equals to 0. Rather, I want to look at the gradient. That is the gradient. And for us to find the gradient, we must express this one in the form y equals to mx plus c, so that we have 3y equals to 2x, and rather negative 2x minus 6. We express it in the form y equals to mx plus c, where m is the gradient of that line which is perpendicular to line L. So we divide here by 3, divide this other side by 3, and this other side by 3, so that we have y equals negative 2 over 3x minus, when you simplify that, it will be minus 2. So the gradient, which in this case I'm going to call it m1, because I'm dealing with the first line, m1 now is negative 2 over 3. And what we know is that when we have got perpendicular lines, we have got a property which states that the product of their gradients is equivalent to negative 1. That is m1, m2 equals to negative 1, where m1 is the gradient of this line which is perpendicular to L, and m2 now is the gradient of line L. So because we have m1, so we are going to have negative 2 over 3 m2 equals to negative 1. I want to find m2, so I can simply multiply both ends by the reciprocal, which is 3 over negative 2. Multiply here by 3 over negative 2, multiply here by 3 over negative 2, so that we have 3 and 3 cancel, negative 2 and negative 2. So m2 equals to 3 over 2. That 3 over 2 is the gradient of line L. And because this is a gradient of line L, and this line L passes through the point P, so we are going to take that point P, which is 8, 6, and we look for any other